So, hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 67, and in this video we are learning again two new keywords. Actually only one, but they are coming in pairs. And the new keyword which we are going to learn is this unsigned and the signed keyword. And when I click on it, and we can read already, this new keyword is used for unsigned type modifier, but this is not absolutely true, because what I mean with absolutely true here is they are also type specifiers, but later more. Let's learn first what this unsigned and signed modifier, what function they have. So first of all, unsigned, the unsigned modifier, like it says the name, it will give a type a sign. In this case, for most time, a plus or a minus. So for example, if we have a signed modifier with minus and we use the unsigned modifier with this new type, it will get rid of this minus. For example, let me show what I mean. It's better. I create here an integer type, and then I create a variable, my negative number, and I assign a negative number to it, right? Let's write it, for example, -5. So, and now I can use this unsigned modifier in front of this integer. Let's use it. Now, first of all, here we know what the outcome is, right? -5 integer, it's possible, and if I put out, we get the normal standard output -5. Oh, okay, I have forgotten to write. Yes, that I should print it out, of course. std out my negative number, and we expect, of course, -5, right? That's no problem. That's perfect. And like we expected. But now I use this unsigned modifier, and you can see it is a modifier because it comes now in pair to the already existing type. And this unsigned modifier is doing something with this int. Actually, it is getting rid of this minus sign here. And when I print out this one, we see something strange, very, very strange. We see a number which is around 4 billion and anything, but we expected 5, right? So that's a big problem here, because I just said unsigned get rid of the minus sign. Why we have here now this big number? And the problem with this unsigned int is there are special tables. What happens if they get rid of this of this minus sign? So let's see what happens here again a little bit. Of course, you have to watch this online or in a C++ book a little bit more in detail, but here only a just overview and how we use it in practical use. But let's get here first in this table. So we have here this integer type. This is my int. This is this one. And the integer can have here size in bits. It can be at least 16 bits, and it goes to maximum 64 bits. Okay, this we have not discussed. This is not very important. But what we have discussed so far is the normal integer, so without this unsigned, is this one here, the signed one. And the interesting thing is we don't see the signed symbol here in front, because by default, it's already this version here, and the default version they skip, which means they don't show it. So normally this integer is all time signed int my negative number. And when we press this, print this out, we see now it's -5. So by default, we have all time this one, but in general, in C++ programming, they don't show this default value. So we write just int. But if we want to use the unsigned version of the integer here, then let's say the one of this one, let's say this one we learned so far, and then you have to use this word unsigned. So which means if I want to use really without this minus, I have to use unsigned to say this number should be used the unsigned version of integer, because this is not the default. So, but what we can see here also is the signed version, which we used till now, all time this normal int was our signed version. And I said our normal signed version has this range, here from -2 billion to max 2 billion anything. I copy this value and I put it here on top so we can see this as a comment. So you can see that was the normal int what we used so far, and I said this int type has all time this range. It goes from -2 billion, if you know this, and then till 2 billion. All these numbers you can write here and it will not cause a problem. And now what happens when this unsigned comes, because that was for the normal signed. Let's write here with signed int. This is the normal. And now let's see what happens what happens when we use the signed with unsigned int. And we watch again this table and we see something strange, right? We see it starts with 0 and it goes now not till 2 billion, it goes to 4 billion, and this number is actually just the double size of this 2 billion. And why is that so? It's very simple. The reason for that is they said I can't use the negative one, so I add the negative one to the positive one. And now we have this 4 billion instead of -2 billion and +2 billion. We have here around only +4 billion. And the reason why they do this is when we watch again this bit size here. The reason for that is, for example, the integer can have at least 60-bit or 32-bit or even 64-bit. It's also possible here in this demonstration. But in our case, it has most time 32 bits, most time. And if it has, for example, this 32 bits, it means I have to use that, or I can use that. Let's say not I have to, I can use that. And that means if this is a 32-bit integer and I can't use anymore this -2 billion, but I have still 32-bit available, then I can give you this range in the positive ones. And that's it, all about this signed and unsigned version, what we have here. Of course, you should read this later a little bit more. And we will also talk about the size bits here a little bit more later. But in general, what this size bit means is this integer, what we use here, for example, it can go from 60, 32 to 64 possible. And it says at least our integer will have 60 bits at minimum. But that means only it is possible to have the minimum size, but it's also possible that the compiler says it's not enough, I need 32. The compiler says no, it's still not enough, I need 64. So this one will decide the compiler later when it's evaluating even if you try to force it. And if you try to force it, it can cause problems. But for that, we will talk this more in detail later, or you read this in a book a little bit more in detail. But what we need to know is how to use this signed. And you see here all time for all other categories, they have also a signed and an unsigned. And signed means most times you have the negative values possible. And unsigned means you want only the positive values. But then the range increases in positive, which means the negative are added to the positive. But now we have still this problem. Why we get here this strange number? Let me show this one again. This strange number, 4 billion thing anything. The problem is here, this unsigned int will not accept negative numbers. And if you write this negative number here, what it does, I can't explain to you that in detail, you have to read this, but in general, what it does is takes the positive number, maximum value, and then it subtracts this one from it. So you can see this value, what we have here, is the maximum range, what it goes. It is 4 billion, and here, this one. And then when you subtract 5, minus 5 of it, you can see it starts with 295 is the first one, then let's make it here, demonstrate it. 295 is the first one, 294 is the second one, 293 is the third one, and 292 is the fourth, and you see 291 is the last one. And this one, I mean this last end here. And if you compare this one here with this one, yes, this one is from the maximum value 5 subtracted, and this is the value added here. So that is not intended, and that can cause error, and that's why I show you this here. So this is a place where if you use, for example, something like an unsigned int and write a -5, you expect, for example, a -5, and then it can happen something like that. And not only with int, it is the same with float, with double, with the other things which we are going to learn too. So this is very important that you notice that this can happen, and if this happens, that you know what this is, that this unsigned will use the maximum range, for example, in this case, int. But of course, we have also discussed, let me show you the other things here. We have also discussed, for example, this is the integer. We have also discussed this character, right? And a character, I said, can have, and you can see a character has only this range of normally 8 bits. Okay, 60 bits, and it can even have 32 bits possible, but only on a certain format, right? This is only, but in general, 8 bits. Integer, in general, 32 bits. So when I say general, it's common, but not must. Careful about this one. And then we have here this floating point numbers, right? This floats, this doubles, this and so on. And they are really big. They start with 32, 64, and then here in these special cases, they go out of range. They probably can't even follow these numbers. Only the PC can follow these numbers. Yeah, but sometimes for scientific and very big numbers, you need even these precisions when you go down to anything, to atoms or whatever. But in our general case, we are working with characters, integers, and floating numbers in normal range, which a human can read. And let me show this character as well. This character we have discussed as well, right? I said, for example, in character, we have this 127, I said. And this 127 was actually this ASCII format. We talked a little bit about this. This old keyboard signs, this ASCII format, and all the signs was here thing. But if you use this unsigned character, you see it's doubled again here. All this negative is added to this one, and you have this range. And the reason only for that is because it uses the full size, full 8-bit size. And you have to remember this all time. If you use unsigned and signed modifier, like it says here, and one that's more, or that's more it about that one. But more important is for us, or let's say one thing also it's important for us, it's how to use it. That's clear. But interesting is it is said it's a modifier, right? And let's go to this table here. But interesting is here it says type specifier, right? And it is listed here as a type specifier, is signed and is unsigned. And what means a type specifier actually? Type specifier means actually this int. It is something like a int, also for example a primitive type, which means actually we can create with this unsigned a primitive type, a variable, right? I can just write unsigned and then I use my unsigned variable. And then I can assign probably a value with it. But the problem with this one is this primitive value type is in general not used. Well, the most people in C++ and Common, they use this as a, like I said before, as a modifier for other types. But if this list is true, actually we can use it just as a type. And that's interesting, but in general you will not see this unsigned and signed value used as a type, because you can see here the second table, it says it is equivalent to an int. So instead of using this signed, they will all time use in general programming in C++ this int, because it is the same. And the same goes for this unsigned, all right, this unsigned int not. All right, it goes also for unsigned, because here they say instead of using this unsigned, we use unsigned int. And there one more info why they are doing this. In C++, of course, you have to read this a little bit more in theory, because this goes in the theory part, and in theory we are not talking too much here in the practical use, but just get a general idea is they try to use all-time int in programming. One reason is for that, because under the hood, I think C++ works well with integers, which means all the calculations and all the things. I read this anywhere, I don't know where now, and they say if you use int, the calculations under the hood, how C++ was designed, works very fast. And if you use other types, they convert it under the hood to an int and back. So int is very, very favorable, and you should use int instead of, for example, this signed, and or even, for example, later we will learn some more. So anyway, that's more theory, but the thing you should know, and this is not a common knowledge, I think this is really not common, that this signed and unsigned, only of course the intermediate and the professionals, they know it of course, but in general nobody is using that this kind are not only modifiers like it says here, that these are actually types. These are really type specifiers, and types are this primitive type, which means they can be used just to create variables like I did here. You see, it's not complaining at all. And I can print this unsigned now also out. That's the point, because this kind of thing many don't know. But as a beginner, what you should use, you should know is that this one is used most time to get rid of this minus, and important here is it is not getting rid of this minus in front of the number, it is getting rid of this minus of range, which means something like that, what I showed you here. It goes then the range from minus 2 billion, the normal integer, becomes, oops, why you don't know our way here now. So the minus 2 billion becomes now starts from 0 and goes now to 4 billion. This minus is now added to the plus sign, and then it can have strange behavior if you give not the right number. For example, if you read an unsigned value, all time use plus 5, and if you use the minus version accidentally and you see in your error or in your debug strange numbers, strange big numbers, then you have to think, it used the maximum range of this int, and then it's subtracted from this one back. So I think I stop here with signed and unsigned. You have to read this a little bit more in theory as well, how these numbers comes together if you want a little bit more knowledge about this. And of course this bit size has a lot to do with that. And yeah, this is a little bit more theory. In practical use, the last word what we are doing is, yes, we are just saying, in practical use is more an indicator that you should use only positive numbers, right? So this one is more, let's say you have here an int like I did, and if there is an unsigned, that means I don't want to use the negative one. So you should use only the positive numbers, and when a programmer reads unsigned, then he knows, okay, I should use the positive numbers, but also he knows I can use here bigger numbers on the same time, because unsigned means the negative numbers of int are added now to the positive numbers, so the range is bigger. So like here, the negative numbers are added to the positive numbers, and now I have bigger range, so I can use more, a bigger range later. And like I said, you have to read this a little bit more in theory, how this all works, and to understand it. In practical use, it's more straightforward and not so yeah, not to thinking too much about this, because like I said, we in practical programming, we see just this word, we say, okay, use a positive number and go on to your task, right? Straightforward, not too much thinking. And you think here in the theoretical part, you think there a little bit more and understand how this all works. So that said, if you have any questions, again, ask in the comments. I try to answer them. If not, perfect. And with that said, bye and good luck.